Well, hi, good morning. Thank you for joining me in my shop. Today is December 5th, and so I think what I'm going to start off with this radio today is testing the tubes in it and get that out of the way. Got a radio that doesn't work here, and there has to be a reason for it. Maybe it's the vacuum tubes. So that's what I'm going to start off with. I think we'll start off with the output tube, which I'm pretty sure is this one right here. $50L6. Okay, we will test that tube. Okay, let's start with 50L6 is written right there. 47, 8, 18H, and more numbers. So we'll start here. 47, that's the voltage. Why not 50? I don't know. 50L6, 8. 18H, 07345. 07345. 0610. 0610. Already set. 43. Oh, right on. C. Oh. I'm not sure why this was set so closely to where it needs to be, but okay. So a good tube will test at 1030, so that's the 1000 mark there. So that's where we want the needle to get to. And the tube. There we go. I have a visitor watching everything I'm doing here. She's getting ready to jump up. That's what she's doing. Jump? No. You gonna jump? Now that we're watching, no. Okay, that tube is glowing. Oh, guess what? So, she's come to really help out. Move on. Keep moving. There she goes. Okay. Looking like a cat. This tube looks ridiculous. The way it's glowing up here. Okay, let's carry on. See what's going on. So, no shorts. Test. Okay, 1000. Well, it comes right up to 1000. Wow, is that ever glowing there? I think it's really 47. Is it really 47? Maybe it's some other voltage. Wow. Okay, but it tests good. It's not the reason why we can't hear anything coming out of this radio. Okay, getting out the next tube. Next tube is 12 SQ7. Okay, 12. 12. I went way too far. 12 SQ7. There it is. Okay, right away we never leave those up. You leave the voltage set high, you run the risk of making a mistake with a lower voltage tube. So this should be set to 13. 13. Okay. Signal levels 1. 18L. 18 already. 25100. 25100. 0. 3760. 3760. 37. And F. Okay. 760 this time, just has to come up to here. This is a multi-part tube, or more than one thing's going on in this tube. You must be able to hear my cat purring. Okay, any shorts in this tube? No. And GM test. A little low. Well, it's still climbing. So it's right at the reject point. What was 760, wasn't it? 760. It's right at the reject point. I think we can still qualify it as a functional tube. I don't think it would explain why a radio is so quiet. Now we're going to do the other part of that tube. 2013P. 2013P. 0760. 0760. 48. A. Okay, back in. P1, P2. A diode test. On a diode test, we only have to come up to about where my finger is here to be good. Okay. Go. Okay, first diode test. It's well into the good. Other diode, a little lower, but still showing good. Interesting that they test differently. Okay, this tube cannot explain why the radio is dead, but it might explain why the radio is weak. Okay, now one more tube. It's not even weak. Oh yeah, what am I saying? What am I saying? My cat is disturbing me here. Okay, get this last tube out. Doesn't want to. There we go. Okay, I had to fight with this one. This one's a 12SA7. Okay, 12SA7. 12SA7. There it is. 13. Signal level 2. 9 low. 27345. 2 7 3 4 5 1650 1650 45. See, here we are doing the whole tube. One test. Okay, now we basically all that's left in the radio is a rectifier tube. It's possible it's implicated in this. Not very likely. Let's see what happens with this tube. So, be bad. If you're bad, this will be easy. Fixing the radio. And this tube should come up to 1100, which is just above 1000 here, about there. Wow! That was kind of weird. Right over. Wow. Well, that's ranking really good, that's for sure. Well, not a tube problem in this radio. Some other kind of problem. So I think what I'm going to want to do is operate the radio again and mess around with it a little more. Well, look who's there. I guess she likes the company. They can't go outside anymore because winter has come. Okay. Coffee break time. That's what it is now. You just wait here, okay, Shadow? Good cat. During my coffee break, I've ended up with this guy here. Hey, what are you doing? Nope, don't want to be up there. Okay, come on. Okay, that didn't work out. Wait a minute, wait. Oh, the poor guy. That was crazy. Now, hey, that didn't work out. This was stuck to his foot. Poor guy. He was freaking out as he was leaving. Okay. Now what? Oh, he's coming back. He wants something. I think he wants to be fed. What are you doing there, cat? What's up? Hey, what are you doing? You want to go out? No. You want some food? Never ever responds to those questions. He never responds. Okay, I think he wants some food. That's my guess. No question about it. He was looking for food. Okay, now let's play this thing and listen to it again. Maybe I didn't give it a fair shake first time around. Very, very stiff control there. There we go. Switch is off. Power's on. 117 volts, but we're going through dim bulbs. Now, does this get as bright? I don't think it gets as bright in here. Of course, we're on a lower voltage. Well, not much, 110. 111. Okay, little radio, here's your second chance at it. Dirty volume control. Oh, smokes. Wasn't that exciting? So there's an oscillation that occurs. That happened the last time too. Okay. Don't think we're going to get any further drawing the radio out. I think what we've probably got here is an open resistor or a shorted capacitor, I would guess. Well, I think probably changing out the capacitors is the right thing to do. Here's an important one right here. So this guy is connected to the chassis at this end. And there's a resistor here. It looks like a 330K resistor here. There's a technique that's been used in this radio that looks like a replacement technique. Let me show you. I'm going to get the close-up camera here. We'll just take a little better look at things. You know, the autofocus may be on here. This may be a little crazy. What I'm talking about. See how the wire has been wrapped, very almost like a wire wrap tool. See, there's quite a bit of it done in here. Where else did I see that? I thought I saw a bunch of it. I guess it's just these two spots right here. Huh. No, you don't see that very often now. What they've done is they've made a connection to the wire lead. And so maybe under those circumstances, this manufacturer says, well, this is the way you got to do it. Because, you know, they don't want to have trouble in these radios as they build them. So they try to build them in a way that is very unlikely to cause trouble at the end of the line. End of the assembly line. So this is the capacitor with the resistor right across it. Made by Aerovox in New Bedford. But this is a different kind. This is a Tiger. Does that really matter? Probably not. Aerovox. So you'd think one supplier would supply a manufacturer. Bedford. So one capacitor from somewhere else. 0.05. Nothing special, but it's very large. .400 volts. They're all 400 volts. Well, I don't know. Who knows why that particular capacitor is a different manufacturer. Could be nothing of any significance at all. Looks original, even though it has this technique used here. Still looks original to me. Okay, who's going to be the first one out? I have to do a little bit of testing here to try to figure out roughly where the problem is. I can localize the issue. That might be easy to do. Okay, I'm going to try that out. I'm going to have a little bit of fun with this radio rather than just, change the parts and turn it on. Oh, phone call. So I think that maybe the first thing I want to try is pounding some signals into the antenna, see if we can get anything to come out the speaker. And my tripod was falling there. So we're going to start with the IF frequency of 455. We're going to hook it up to this antenna on the radio here and just try to force a signal through the radio. So not connected yet. Turn the radio on. There we go. So the radio is tuned about halfway, so maybe around a megahertz or so. See if we can get something to come out of the we could do a little cleanup on that too. Things smell just a little smoky in here. Usually these things go silent. I clean right up. Good enough. That buzz is interesting too. This buzz. That suggests something. Okay. Turn it up. And now we're going to beat it up with a signal here. That's a very strong signal. Not connected. Not connected. So we're going to connect this to the antenna here. Didn't make a sound out of the speaker at all. No clicking or... We're not going to get it. Oh my gosh, we are going to get something. I'll take that back. Way up at... Whoa! 490. What's it doing up there? That seems to be way, way, way off. Okay, let's try receiving a real signal. We think this is around a megahertz, strong signal. Okay, let me just make sure it's higher than that. So that would be, oh. How do you like that? There it is. I was tuning the radio. Right at the limit of my guy here. Let's just put this up here, tune it in on the radio. Okay, so it is receiving. This is a very strong signal, but not a crazy strong signal. But that would be probably a lot stronger than you would ever get off the bundle of wire that's on the back here as an antenna. If I hook it up to an outdoor antenna, are we going to hear something? Am I actually going to be able to pick something up? Let us give it a try. Now this antenna is not switched on. I'm going to have to run and switch it on. This is just the lead-in. The oscillation seems to be gone. We're running the radio at 115 volts. Okay, let me go down and switch the antenna. Here, I'm going to leave the video running, so it's just going to be an empty room for 14.1 seconds. 14.1. Okay. Oh, it's definitely picking something up. I can hear a little bit of noise. That's full volume. Probably 590, the sports channel. I don't know if you can hear that. That's really quiet, but it's there. Okay, that's interesting. That's pretty interesting. I'll shut her off. It's working a bit. That's interesting. Who among you capacitors could be doing this problem? Causing this problem? Won't be this one, the grounding one. Let's look on the schematic and see if we can just kind of guess which one is 1, 2, 3, 4, 5 wax capacitors could be doing this. It's not necessarily a wax capacitor, but that sounds like fun. Let's take a look. Yeah, I'm pretty weird that this kind of stuff sounds like fun, that's for sure. Well, we have a signal coming in. And so proper capacitance, weak capacitance, shorted, or open. Those are the 4 conditions that we can consider here with a capacitor like this one. So what is this one doing? So this is connecting from here to basically ground. We can call this black wire ground. And the idea is to put a ground on this coil, because at the same time they're sneaking something through? No. Cathode. What is this wire here? Screen. So this wire must be getting a feed from the I'm lost. Okay, I'm all lost on this schematic. Let's just carry on with what we were doing. So this is a possible problem spot. Shorted at I'm not sure what to say. I don't know what to say. Let's just carry on here. And then find another. Here's 50 picofarad, 100 picofarad, 100, 20, 20. Where are those guys? Here's one, 0.01 here. This one can't silence the radio. Unless it's shorted. Then we would have a bigger issue here, I think. That would make the speaker really faint. But I think the speaker circuit, I think this is working okay here. I think the signal getting to the grid is weak. Coming out of this tube is weak. Go down to the volume control. So it's all going through this capacitor. Now if this capacitor is open or has lost its capacity, that would silence the radio quite a bit. Maybe we should do this one first. This is the guy right off the volume control. Let's do that because the whole audio goes through here. Let's eliminate this one as a problem. 0.002. Okay, right off the volume control. It should be pretty easy to spot. Here. Okay. Yeah, actually, this goes straight to the center terminal of the volume control. And the size on it, watch out, this capacitor could be charged. It's going to be 0.002. That's it. That's the guy. He looks to be in great shape. I can't imagine it's actually causing a problem. But let's go at it. Okay, we're going to nip it here. And I'm going to try to get it. Got something. This looks perfect. Okay, it looks so perfect. I'm going to try it right off the bat on this tester here. Now the thing is, if a capacitor like this is leaky, these capacity tests seem to read high all the time. So you get a false reading. Let's see. That's a 0.0026. So, but it shows V loss nothing. Should be 0.002. Where's the 6 coming from? Okay, we're going to put this on the classic vintage capacitor tester. Yeah, it's a vintage machine testing vintage capacitors. Vintage, I don't like that word. I like the word antique or old. Vintage, that's supposed to go with wines, isn't it? Okay. So the way this works, you watch the eye. The eye is open, there's no current flowing in the capacitor circuit. If the eye is closed, there is current flowing. It takes just a tiny amount of current to close this eye. I'm going to throw this switch. It's going to apply 50 volts across here for a brief period. Current will flow. As it charges the capacitor, the eye will close. But once the capacitor gets full, which is pretty quick, the eye will pop open. And it happens in about a second. Here we go. So this is suggesting a problem with the capacitor. It really should be snapping closed and opening. It shouldn't be popping open that suddenly. Now, how is it we gotta, let's go up another. So this is now 150 volts. That's more normal. Okay, let's measure its capacitance using this device here. Flip over here. This is a 0.00. What did I say? 0.005? Okay, now we should be able to find it. Watching the eye again. There's where it pops open. Okay, and on the scale, this would be 0.0026. Huh. Isn't that exactly what that other device said? Well, generally if the eye's not opening very much on this test, it suggests to me there's a bit of a leak in the capacitor, but I'm not sure of that. I don't know, you get a little bit of conflicting test results. Generally I'd say all those tests combined suggest that capacitor cannot be responsible for the quiet operation of the radio. Now there's something else too. When I turn the volume up, you could hear a kind of hum. I would call it the open circuit hum, where you have a input to an amplifier and you've got nothing plugged in, and so the amplifier's input is just open to space, and it can be influenced by noise signals and stuff like that. Turn the volume way up and you can hear this hum, buzz, a buzzy hum. That's what I could hear out of there. This capacitor, if it has no capacity, although the test suggests it does, would cause that kind of problem. Exactly that kind of problem. And low volume throughput. Okay, well that's all interesting theorizing. I'm going to put another 0.002 capacitor in there, and we'll see if the radio's improved. Maybe I got it already. Well, that took quite a while putting that capacitor in there. Okay, now we're ready for another try. Volume should be down. Okay, switch is on, volume down. Dim bulbs behaving normally. Volume up a bit. And we still have the signal generator running, just around the million mark. Okay, same buzz. It's okay, we're hooked up to the antenna, not the signal generator. Not very acceptable, but we know it's not that capacitor. And I have to run to the grocery store now, so this might be the end of the video. It depends how things go today. So if it is, thanks a lot for watching. If it's not, who knows what I'm doing next. You know what, I think I'm going to make this the end of the video. That's what I have to do for practical reasons. Okay, well, we'll carry on tomorrow. Do another capacitor or two, and we'll nail down why this radio is so quiet. Thanks for watching.